Welcome back to the Advanced Keras Construct walkthrough. In this, we'll be covering the part two, where I shifted from high-level APIs to the core of TensorFlow and Keras. This walkthrough highlights how I built everything from scratch: custom layers, loss functions, optimizers, and training loops. In the first section, I defined custom layer like exponential layers. And in this notebook, we'll be using the custom training logic with full control over gradient and losses and custom components like layers, loss functions, metrics, schedulers, and callbacks, initializers, and constraints, and the other regularizers. So we start with importing the libraries, load the preprocess fashion MNIST model, and then we define custom layer rate callback. We use the Adam one, and then once we're done with that, we define custom dropout MC alpha drop style, and then we defined a simple CNN using custom dropout. It is a convolutional network, and we compile and train the model. This is what the accuracy we got, 90%. Then we use the custom loss function, Hubbard loss here. Then we use the custom metric inverse of Hubbard loss for simplicity. Then we use the custom activation function and we use custom initializer in this. And then we are using the custom constraint. We force weights to be positive here and define a layer using all custom components and then test all the layers. And then we use custom Gaussian noise layer and we then form a residual block. And after that, we use custom model using residual block. And once we're done with that, we are making a class of custom optimizer here. And then we manually do the training loop. Once we're done with that, we'll evaluate the model. We got the accuracy of 82%. And this was the fashion MNIST model data. Um, what we predicted, we got like the summary is like we implemented custom components, loss metric layer optimizer, built custom residual model, and with projection logic and ran training loop with annual gradient tracking and evaluated and visualized prediction successfully in this one. In this notebook, we'll be building custom layers like exponential layer, add Gaussian noise and MyDense, creating a residual model block from scratch, and we'll be implementing our own optimizer, which is my momentum optimizer, and we'll be running a fully custom training loop on the fashion MNIST data set. We start by defining exponential layer. So this is how it looks like. We define the Gaussian noise layer here, and we define custom dense layer here. After we're done with that, we'll test the layers. So this is what the shape of the layers look like. And then we perform custom residual block using MyDance. And then we have this residual block, and then we do the residual regression. After fixing the constructor, and then we have this custom simple optimizer and with us, and then we prepare the data and the model, and here we are performing the training loop. Once we're done with that, we'll evaluate the model on test data, which we got 81% accuracy over here. This is some predictions, and the summary here is we built custom layer exponential Gaussian noise Midance layers, and then we implemented residual block and full residual regressor. Then we created custom optimizer, wrote full manual training plus done the evaluation loop and visualized prediction and validated the accuracy as well. Thank you so much for watching. I hope you learned something out of this.